means we have a list of data. Simple as that. Sometimes the list is arranged horizontally because it takes up less space on a page. Sometimes it's arranged in columns and you have to type in several columns. But your calculator expects that you can interface, go from a list in printed form to putting it into the calculator phase, and it will dump information for you. So here's the beginning note set for what we deal with in the problem with some symbolism in them. When we talk about measures of central tendency, we're talking about where data tends to cluster, where it tends to group together. 3 measures of central tendency that we use. One is called the mean, also known as the arithmetic mean. Arithmetic, that's arithmetic, but when we use it in front of mean, it becomes arithmetic, not arithmetic, okay? So the arithmetic mean, in your language, you will probably remember that as nothing more than average. But to a statistician, average means something different than arithmetic mean. So although we think we all speak the same language, we don't get the same understanding if we're not careful about the way that the language is used. The mean of a distribution, the mean of a list of data, is a way to describe the central tendency, and you can think of this as how we get the weights balanced. Let's say we had 10 people that were lined up and we were trying to find what the average weight was. From a visual standpoint, we'd put these people on some kind of a balance beam, and we'd be looking for where to put the fulcrum on that balance beam. So some of you may not understand what I'm talking about. Some of you may remember, I don't know when they took them off of playgrounds, but they were on playgrounds when my kids were growing up. I don't know about you. There used to be things on playgrounds called teeter-totters or seesaws. They're not there very much anymore because they're a legal liability. There was always one kid, one mean little kid, usually a boy, sometimes a girl, that sat on one side of the teeter-totter, and they were bigger and heavier than the person who was on the other side, and they were up above the ground, 5 feet above the ground, squealing, let me down, let me down, let me down, and they immediately jumped off of the teeter-totter, and that person comes crashing down from 5 feet. It resulted in broken bones. So legal liabilities for playgrounds, they took them off the playgrounds. They're still in some of the splash pad things, well, not with a splash pad, but they're now on a spring-loaded system. So someone that's holding you down and jumps off, it doesn't go all the way down, it just kind of slowly balances you back down. So they're still there, but basically what that does is it tried to take the people that you had and arrange them so that the amount of weight you had on this side was the same thing as the amount of weight you had on that side. And from a child's game of seesaw or teeter-totter, and somebody in the last class told me, oh, you're talking about up-downs. Yeah, I guess so, because you go up and down and up and down and up and down. So they call them up-downs, okay? Different term, different part of the country. But that's what happened. If it was a fair game, then you could go up and down and up and down and up and down, and everybody got fun and enjoyment out of it until somebody got a little bit rotten and ruined the routine. So that's what you have to think about with a seesaw, with a teeter-totter. It doesn't mean that you'll have the same number of people on this side as you'll have on this side. For example, if I'm carrying 4 boxes of something and they're not all the same weight, I have to be careful about picking up those boxes so that I'm not too lopsided. So let's say that we had boxes over here. There was a 10-pound box, and there was another 10-pound box, and there was another 10-pound box. I'd have 30 pounds of weight on that side. If I want to balance the weights, I need to have a box that's got 30 pounds over here to be able to balance the weights. So measure of central tendency from a visual standpoint is just basically trying to balance the weights. You might remember pan scales out of junior high, middle school, something like that, or maybe in a chemistry class or an earth science class you had somewhere along the line. It's the same basis, the same principle. Trying to balance out the weights in the problem. The problem with trying to balance the weights is that it isn't always necessarily going to be exactly in the center. But that's what we get when we look at an arithmetic mean or a mean value. From a symbolic standpoint, you're going to see written formulas out here that talk about capital Greek letter sigma to a mathematician, meaning summation. Add together. Add together all the individual values, divide by the number of values, and that gives you the value that we consider to be the mean usually represented, and for our purposes represented with an X with a bar over the top of it. Strangely enough, that is read when you read it as X bar. Mathematicians aren't really imaginative. They pretty much tell you exactly what you're looking like, okay? So that X bar value is the symbol that you will see on your calculator, that you will see in print. You never have to be able to type it. It's not an icon you can pick up off of the bottom of the screen, because they never expect you to type that. It's always in the front, like when you're solving equations. It always gives you X equal. It gives you that part of the problem. But it's referred to as being X bar. That is the primary measure of central tendency. It is not necessarily the best measure of central tendency. The mean value, because it takes the voice or the weight of every value that's involved in the problem, can be distorted if there are some loud voices or some large weights, or some small voices or some small weights. Give you an example of that. If these were the first 4 grades on your 5 English papers at the end of the semester, what kind of an average would you have right now? Would you feel pretty comfortable? Because you're immediately translating that to an A would be 90 and above, something like that. So this gives you an average that's going to be 90 or above. So you're feeling pretty good about this, right? Hoping for an A in the class. What happens if your next paper comes back and you had a nightmare? What's that going to do to your average? A little or a lot? Is this excessively small compared to the other values? So mean values, average, when we talk about average, it's affected by every value that you have. And if you have an excessively large value or an excessively small value, it can give you a distorted opinion of what an average really is. This was a class where the first question you'd be asking the English teacher is, do we get to drop our lowest paper? Right? Okay, so when you ask me that, I'll say, no, we don't drop it, but we will replace this with the percentage grade on the final. So does it give you a chance to get a better grade? But if your final exam grade was a 15, you're still screwed. But you have a chance, okay? It's not going away forever, but it can be replaced by something else, so it gives you a chance to kind of delay and get better with something up there, okay? So I'll give you another example of that. If I were to ask you all to give me a number figure representing the amount of money that you could get access to in the next 24 hours if you had an emergency of some sort, meaning how much money you have in your wallet, in your book bag, in your purse, in your debit card or something like that, excluding credit cards, okay? I'd get a number from all of you. Might be an honest number, and just for argument's sake, let's say that the number that I came up with when we added them all together and divided by the number of people that responded to that turned out to be $200. Does that mean everybody has $200? No. Some will have more, some will have less, right? If Bill Gates walked in, what would that do to the average amount of money that we had access to?
Raise it.
Would it raise it? A little or a lot? A lot. A whole lot. Wouldn't that be nice? Especially if you agreed to share this money with us, huh? Probably not going to happen, okay? But excessively large and excessively small values are threats to the reliability of a value called the mean. And there are some questions that target that in the exercise we deal with, so we're mentioning it here, and then we're going to show you what it does to a distribution sort of along the line. Another measure of central tendency is called a median. Median has no special symbol to abbreviate it. Sometimes you will see them use a capital letter M to represent median, but that's not necessarily a given. They'll usually write it out into words. Median is designed to take the data set that you have and break it up into 2 groups of equal size. The median is a number value, so in trying to break these numbers up into 2 groups of equal size, what we have to do first of all, if we're not using the calculator, is to arrange the data in sequential order. Now, problems there is that sometimes we get different values when we look for a middle value. But we'll have a screen for that in a second. Median value measures the central point not on what amount of money you have, but on how many people we have. So if there are 30 people in here today and I want the median value, I would take the highest 30 earners and the lowest 30 earners, and I would take those two values that are closest together and find out what would be between them.